So that's an important point. Like, it's the increasing use of an explanation and reference to that explanation that give you trust that the explanation is true. So similarly, if you want to believe in God, that belief must be useful. Otherwise, it's likely to be dismissed. Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah wa barakatuh. Still, chapter 2, section 3, believing in the unseen. So one knows about the world through the senses and also through the tools one possesses, like the sense, the sight, smell, hearing, touch, taste, but also the tools. If I take a microscope, I can see a bit better. It's a tool. If I take a telescope, I see further. So the perception of the outside world is the proof for its existence. Scientifically, that's the ontology. That's how we understand the world. You believe that things exist, that whatever you can perceive, like materially, exists. However, most of the time one cannot see, taste, touch, feel, or hear directly certain object whose existence is perceived only through indirect means, like the electron we mentioned before. So such indirect experiences are, in many cases, sufficient to establish a conviction. In what follows, I shall enumerate some examples of established scientific concepts that solely rely on indirect evidences. The first one, the electron. I mentioned it already, but it's an important one because it's quite explicit. So as common as they are, no one has ever seen an electron, but only the effect can be seen. So one sees only the lightning in the sky, or the spark of a gas lighter, or sees the light that is emitted through the passage of electron. But we don't see the electron themselves. We only see the effect. So to be more specific, in an electric arc, when you see the spark, the way it works, the electron moves across the air. The air usually it's an insulator. The air does not let electron pass through itself easily. So it's like if electrons have to force themselves through air, they will jump from one molecule of air through the other. And because these molecules, they don't readily accept electrons, when electrons are forced to pass through them, they break up. These molecules break up. The electron passes, the molecule can recombine, and when they recombine, they'll emit light. That's one way how to see it. So you don't see electrons. You only see the light that is produced by the passage of electron through air. So in the same way, when using electric appliances, one only see the consequences of the passage of electron. For charging, you see the phone charging. You don't see electrons going into your phone. So you see, for example, the motor turns, the light is emitted, the stove heats up, etc. So one can only feel electrons indirectly. Even when you're electrocuted, for example, that feeling of electrocution, it might seem direct, but you can still call it indirect. Why? Because what you feel, what your brain perceive, is a bunch of action potentials that were triggered by these electrons going through your skin, for example. So you can still call it an indirect experience. Even when you measure the current these electrons produce, what you see is a needle that moves. You don't see the electron directly. Although it is accepted that electrons cannot be directly perceived, no one dares denying that these electrons exist and that they are constituent of each and every atom. So once considered as the product of an obscure theory, their existence today is not even questioned. It is in fact the increasing use of and reference to the electrons theory that reinforces one's conviction that electrons do exist. And that's important. Why? Because if you look at theories for maybe more than 100 years ago, so before 1900s, electron was just maybe a theory. There were no practical experiment to prove that they exist. the most common theory was the ether theory. And I guess the beauty of Einstein was to not use ether in his theory of relativity. He didn't mention the common theory of ether for his theory of relativity. That was one of the biggest steps that Einstein did. He just dismissed a whole framework. Whether he did it on purpose or not, I'm not sure. But that's the beauty of it. And because he didn't mention the ether theory, it opened the door for new theories, like electrons. A second point interesting about Einstein's theory of relativity, initially it was dismissed. For more than 10 years, for more than a decade, it was dismissed. Why? Because it had no practical applications. It was a nice theory. It's like, okay, you can... Firstly, I mean, it's not even nice. It was already a complicated theory, and it didn't have any practical applications. So people dismissed it. Which means that if the theory cannot be applied, it is likely to be dismissed. Einstein theory only became important when you could find application to get more specific and more accurate predictions. Then it was taken into account. Then it became relevant to the modern world, modern scientific world. So that's an important point. Like, it's the increasing use of an explanation and reference to that explanation that give you trust that the explanation is true. So similarly, if you want to believe in God, that belief must be useful. Otherwise, it's likely to be dismissed. It must be useful, and you must maybe not use it once a year, but if you use it every day to explain what is happening around you, to make sense of what is happening around you, your belief will get stronger. جزاك الله خيرا. السلام عليكم ورحمة الله وبركاته.